Here's a clear and detailed explanation of each auxiliary system in electric vehicles, EVs, including how they work and their importance. 1. HVAC system in EVs, heating, ventilation, and air conditioning. How it works. In traditional vehicles, cabin heat is taken from engine waste heat. But EVs have no combustion engine. EVs use electric resistance heaters, PTC heaters, or heat pumps for heating. For cooling, a compressor powered by the battery runs a refrigeration cycle, similar to home AC units. Types of HVAC in EVs. Resistive heating. Simple but consumes more energy. Heat pumps. Transfers ambient heat inside, more efficient, especially in mild weather. Battery thermal management integration. Some HVAC systems also help regulate battery temperature to protect lifespan and performance. Why it's useful. Maintains passenger comfort regardless of outside temperature. Affects driving range. Heating systems are one of the biggest consumers of energy after the motor. Ensures battery health when linked to battery thermal management, especially in extreme climates. 2. Power steering and brake systems. How power steering works in EVs. EVs use electric power steering, EPS, instead of hydraulic systems. An electric motor assists the steering, only consuming energy when the steering wheel is turned, improving efficiency. How braking works. EVs use a combination of braking and friction braking. Regenerative braking. The motor runs in reverse to slow the car, converting kinetic energy back into electricity and storing it in the battery. Friction brakes. Engage during emergency or full stops or when regen braking is insufficient. Brake-by-wire. In advanced EVs, traditional mechanical linkages are replaced by electronic control systems. Why it's useful. Saves energy through regenerative braking, adds up to 10 to 30% to range. Enhances control and safety, e.g., ABS, EBD. EPS reduces parasitic loss and allows for adaptive steering, e.g., lane assist. 3. Lighting, displays, and instrumentation lighting. EVs use LED lighting for all exterior and interior lights. Some advanced models have adaptive headlights, matrix beams, and signature lighting. Displays. Replaces analog dials with digital instrument clusters, touchscreens, or head-up displays, HUD. Shows battery level, range estimation, drive mode, regen status, etc. Infotainment and controls. Integrates climate control, navigation, media, and even charging information into a central touchscreen. Connected to voice assistants, gesture control, or smartphone apps. Why it's useful. Provides real-time feedback on driving efficiency and system health. Reduces driver distraction with centralized controls. Boosts safety and aesthetics with modern LED lighting. 4. Telematics and smart features. What is telematics in EVs? Integration of communication modules, 4G, 5G, GPS, Bluetooth, for data sharing and remote control. Managed via onboard diagnostics, OBD, ECUs, and cloud platforms. Smart features include remote battery monitoring, via app, preconditioning cabin temperature, find nearest charging station over the air, OTA, software updates, vehicle tracking and anti-theft, driver behavior analysis. Why it's useful. Increases convenience and automation of repetitive tasks. Helps optimize trip planning and charging behavior. Enables remote diagnostics, reducing service visits. Adds features like geofencing, valet mode, or child lock control remotely. HVAC heat pump, compressor, evaporator, cabin comfort, battery temperature regulation, power steering and brakes, EPS motor, regen braking system, energy savings, better control, range extension, lighting and displays, LED lights, digital cluster, HUD safety, energy efficiency, intuitive driving, telematics and smart features, GPS, 4G, apps, OTA updates, remote control, smart navigation, diagnostics, user comfort systems, auxiliary systems, HVAC system in EVs, power steering and brake systems, lighting, displays, and instrumentation, telematics and smart features.